Okay, this is trying to test Coulombs law. So I had a lot of trouble getting the balloons to get some electrostaticness to them. This string above me is about a meter off the ground, and there's a bit of a tangle there, so I'm going to untangle that now. And the idea is, with Coulomb's law, the force that occurs because of the electrostatic charge will force the balloons to move apart. Now, you could measure how much that force is by knowing how much gravity is affecting this as well. So they're not only in an electric field, but they're also in a gravitational field. And these balloons are 3 grams each, give or take. The air actually doesn't make a huge amount of difference to the mass, and they're in a gravitational field and being pulled downwards. Now, in theory, if I grab one of these balloons and I rub it with a bit of wool, it should get a negative charge or a positive charge. I'm not sure which it is. I think the wool takes the electrons off the balloon, making them positively charged. Now, when they're positively charged, they should push away from each other, and using the angle that the thread will make with each other, and these threads are about a meter long, so it makes it a bit easier. Yes, look at that! Come on, settle down. Settle down, settle down, settle down! Look at that! All right. So they are actually separated there by the electric field. And that angle, you can't see it there, can you? Let's put the angle, let's put that up there so we can read the angle. I'm just going to put this as close as I can to the ceiling as I can get. And it's not working. Oh wow, it's attracted to me as well. That's a problem. How about? Oh no, we lost the charge. Anyway, they were a little bit more apart than that, but I would say that the angle at the top there. Now we could probably just do this by measuring the distance apart they were, how far apart they were from each other. But then we can't do the next step. Ah, bother. Bother, bother, blow. Stop following me. Ruddy things. Let's charge you guys up again. Let's charge you guys up again. No, don't fall off. Ruddy thing. Ah, okay. You're very charged. Try you one more time. My guess of that last one was they were probably about so probably the best use you'll ever have in a tropical country for a woolen blanket. Come on. Look at that. Look at that. They just stay apart. Look at that. That's amazing. I truly love this. They're not quite they're not the same height. Bother. Okay, let's see if we can fix that. You two. All right. Settle down. Settle down. I'm just going to read this for myself at the moment, I think. It was about 10 degrees apart before they discharged on my shirt. But even in their state where they were just level with, yeah, well, it wouldn't have been much more than about 10-15 degrees. Might have even been easier just to get about 22 centimeters between them. So they would have gotten about 22 centimeters there. That was about the distance between them, I think. So you can work with that, but now I can't get the same charge on them again. It's been very finicky. 1 and mass 2 were equal to about 3 grams. And the length of the string was about a meter. We're estimating here. The angle at the top was about 15. I don't really know this. 15 to maybe about 20 degrees. This could be very, very off. You can double check that with the 20 to 22 centimeter gap at the bottom. Now, I highly doubt we'll be able to improve on this by being able to add the weights. If I was to add weights onto there, you have to get the measurements correct as well while you're adding the weights. I could do this. How could you do this? But touching the string would make it discharge on me. All right. I will try to do this experiment again, but for the moment, see if you can work out what the force was. And you can use that using the laws of gravity, the universal law of gravitation. And from that, you work out the charges on those balloons. Okay? And you work out the charge on the balloons. So you can assume that the Q1 and Q2 are equal and the same. So the product of those two is what you would get in Coulomb's law, and you assume the masses are the same as well. The distance between them you can work out. You'll have to do some vector analysis to be able to work out what their movement downwards is in the field. We're just going to assume that Coulomb's law is correct. I don't think we'll be able to get a proof of Coulomb's law here.